Now that your team has planned your research project, turned in your proposal, and it has received approval, the next step is to roll up your sleeves, get to work, and implement your plan. To have a successful outcome, you will need to manage your project. Your challenge will be to achieve your project's primary goal within the allotted time and resource constraints, a few students with limited time. This is a publish or perish seminar, and you do not want to perish. Thus, as famously stated by Gene Kranz, the Apollo 13 mission controller in Houston, failure is not an option. Split up the work. Different team members will have different skills, so split up the work and tap into their native skills. Some students will have more time to devote to the project than others. Not a problem. Contributions in scientific projects are never equal and shouldn't be. This is not a student academic exercise. Let the eager beavers run with the ball. Cheer them on and support them. What counts is a high-quality, published research paper. While you have stated fairly specific goals in your research proposal and your instructor has tried to keep you from being too ambitious, you need to keep in mind the true and famous quote from the German military strategist Helmuth von Moltke. No battle plan survives contact with the enemy. Thus, you will not be able to implement your project as planned, no matter how carefully it was crafted. Does this mean that planning was a waste of time? Not at all. As famously said by Dwight Eisenhower, plans are useless, but planning is indispensable. When your project meets the real world, it's not the real world that will yield to your plan. Rather, you must adapt whatever you're doing to the circumstances at hand. No matter what the stated goals are in your proposal, your true overriding goal should be to complete some project all the way to a high-quality paper submitted for publication on schedule. You can do this more or less by hook or crook, whatever it takes. Second only to being too ambitious to begin with, the most common mistake by student research teams is to spend too much time gathering data and analyzing it. This cuts short the time that will be needed to write and polish their research paper and prepare their final project presentation. It is almost impossible to overestimate all the time it will take to write and polish a paper. Several rewrites are always required. This takes lots of time, and this is just to get instructor approval. Then there is the external review. It is good practice to start your paper early on and write as you go. With some foresight, you can write your proposal in a manner that much of what you write can be part of your final paper. Make things do double duty whenever possible. Keep in mind that since your paper will be published, reputations are on the line, including yours, the instructors, and the school's. Thus, the paper must be near perfect. As most of your team members will not have written a published scientific research paper before, achieving near perfection on the first go is a time-consuming, difficult challenge. Fortunately, you will have considerable help. Keep a sharp eye on your schedule. A good schedule will leave at least half of the total course time left to write and polish the team's paper. If it looks like there is not half the course time left for writing and polishing your paper, then you need to scale back early on, as your original plan was too ambitious, or you didn't leave slack time to handle the unexpected difficulties that always arise. If you find yourself falling behind, trim your project down to the bone. Toss overboard any frills or extras from your sinking ship. Often, mere trimming may not cut it, so keep plans B, C, and D handy. A good example is a team that plans to make their own CCD astronomy observations but run into equipment or weather problems. Smart teams switch their plans early on to making remote robotic observations. Really clever teams plan this remote observations option from the beginning, thus not subjecting their project to the hazards of equipment difficulties or bad weather. Super clever teams often go for already observed but unused data, eliminating observational problems entirely. Avoid mission creep, the gradual broadening of the original objectives of your project. As you get into your project, you will find many avenues you could explore, additional observations that would be nice to make, etc. However, instead of adding to your project, you should probably be figuring out how to trim your project. Concentrate on the core. In science, essentially everything you do has to be clearly explained, references cited, and defended. Anything you want to add to your project will be opening up a can of worms. Speculation is rarely allowed in scientific papers. Thus, for instance, if you suggest that the double star you observed may not be a mere optical double. You will need to justify why this might be the case. This is fine if you have the time to do this, cite the references, etc. But if you are short on time, you might be better off just reporting the observational facts, your measurements, and letting it go at that without any astrophysical speculations. Science is an unusual team sport. Imagine a sport where, after the game begins, you can add as many team players to your team as you want. This isn't fair in a zero-sum sport with even teams. However, because science is open-ended, essentially all is fair. Do whatever it takes to conduct first-class research and produce a high-quality published paper. A good ploy, either to begin with or after you get rolling, is to bring in outside experienced researchers on board your team. Offer them a co-authorship and tell them you would really appreciate their help. This is not a classroom or laboratory unpublished student exercise where getting outside help would be cheating, so don't be bashful about getting help. Reputations are on the line, and failure is not an option, so do whatever it takes to come up with a winning contribution. Many of the most important scientific discoveries have resulted from problems or unusual glitches encountered during the course of a research project. The alert scientist pursues unexpected results wherever they may lead. However, this can be time-consuming and, unlike many research scientists, your time is strictly limited. What to do if, as often happens, you run into the unexpected? One approach is to note the unexpected, but continue on with your plan if it will still work, and get your published paper out on time. After you complete your originally planned research, you can then, if you have time and are so inclined, pursue the unexpected as a second research project and publish the results after the seminar is over as a second paper. 2 papers are usually better than 1. Another approach is the old switcheroo. When the unexpected arises, you can make looking into it your research project and scrap your original project goals. If a problem in your research has halted progress on your project, perhaps you can investigate the problem and write a paper on the problem itself. Even if you don't entirely solve it, you can make the unexpected be your research. Research is about the unknown, so unlike lab classes with well-known outcomes, you will be exploring the unknown with often uncertain or untested tools and techniques that may well be unfamiliar to you. Expect the unexpected. To further complicate things, if it isn't published, it isn't science. Published scientific papers have to be exact, concise, and well-referenced. They must be rewritten and reviewed until they are nearly perfect. Poor papers are not allowed, as reputations are on the line. Yours, the instructors, and the schools. This research seminar is publish or perish. Since we don't want any students to perish, failure is not an option, so every team needs to submit a paper for publication. All this creates a very tall order for student researchers. Fortunately, you will receive considerable expert help and guidance. Charge onward with confidence.